Welcome to Intelligence Gateway.
System Vulnerabilities. Lecture 16.5. Topic objectives. Tasks. Describe a range of systems that can become vulnerable to attacks including networks, software, operating systems, mobile devices, physical devices, and cloud computing. Networks. Weak or default passwords. Insecure passwords for network devices, routers, and switches can be exploited by attackers. Unpatched software. Failure to apply security updates and patches can leave network equipment vulnerable to known exploits. Denial of service DOS attacks. Overwhelming a network with excessive traffic can cause it to become unavailable to legitimate users. 2. Software. Software vulnerabilities. Flaws in code can be exploited by attackers to gain unauthorized access or control over the system. Unsecured APIs. Inadequately secured application programming interfaces. APIs can be exploited to manipulate or extract sensitive data. 3. Operating systems. Outdated software. Operating systems that are not updated regularly can have known vulnerabilities that attackers exploit. Privilege escalation. If an attacker gains low-level access to the OS, they may try to escalate privileges to gain administrative control. Merit. Describe the vulnerabilities and threats that these systems may be exposed to. Merit is a non-profit organization that provides various services, including network research and education. As a result of its activities and the systems it operates, there are potential vulnerabilities and threats that it may be exposed to. Keep in mind that my knowledge is based on information available up until September 2021, so there may have been advancements or changes since then. Here are some general vulnerabilities and threats that any organization, including Merit, could face. Cybersecurity vulnerabilities. Like any organization with network infrastructure and computer systems, Merit may face vulnerabilities related to software and hardware. These could include unpatched software, misconfigurations, weak passwords, and insecure network protocols. Phishing attacks. Merit employees might be targeted by phishing emails or social engineering attempts, which could lead to the compromise of sensitive information or credentials. Malware. The organization's systems could be exposed to malware, like viruses, ransomware, or Trojans, which can disrupt operations, steal data, or extort money. Denial of service DOS and distributed denial of service DDoS attacks. Attackers may attempt to overwhelm Merit's network or systems with a flood of traffic, causing services to become unavailable. Data breaches. Confidential information, such as user data or research findings, could be compromised due to inadequate security measures or cyber attacks. Distinction. Discuss why different types of computer systems are exposed to different threats and vulnerabilities. Different types of computer systems are exposed to different threats and vulnerabilities due to a combination of factors, including their design, usage, and the environments in which they operate. Here are some key points to consider. Operating systems and software. Different operating systems, e.g., Windows, macOS, Linux, and software applications have distinct security architectures and coding practices. Vulnerabilities in one system may not apply to another, due to differences in how they handle memory, execute processes, or manage permissions. Attackers often target specific vulnerabilities in widely used software to maximize the impact of their attacks. Internet connected versus offline systems. Computers connected to the internet are more exposed to external threats compared to isolated or air-gapped systems. Internet-connected systems are accessible to a broader range of attackers, whereas offline systems may require physical access to exploit vulnerabilities. End-user behavior. Human actions significantly impact the security of computer systems. Different types of users have varying levels of security awareness and may inadvertently engage in risky behavior, such as clicking on phishing emails or downloading suspicious software. This behavioral aspect can make certain systems more vulnerable. Critical infrastructure. Systems that control critical infrastructure, power grids, water facilities, transportation are prime targets for cyber attacks. The consequences of successful attacks on such systems can be severe, leading to disruption of essential services and potential loss of life. Hardware differences. Vulnerabilities can also stem from hardware components. For example, some computer systems might use outdated hardware with known security flaws, making them more susceptible to specific attacks. Specification coverage. Introductory task. Think about all of the technological devices you have in your home. For each device, state the name of the device, how old the device is. If never versions of that same device are available, how often the software gets updated. Do you know the answers to all of these questions? What do you think the risks may be of not knowing these answers? Pass. As an AI language model, I don't have access to external information beyond my training data, which has a cutoff in September 2021. While I can provide answers to a wide range of questions based on had I been trained on, there might be limitations and gaps in my knowledge. The risks of not knowing certain answers could include providing incorrect or outdated information, as well as being unable to address specific events or developments that have occurred after my last training data update. This could potentially mislead or confuse users seeking the most up-to-date and accurate information. It's crucial to verify critical information from reliable and current sources, especially for important decisions or matters of significant consequence. In situations where precision and the most recent data matter, consulting real-time sources and subject matter experts is essential. As an AI, my responses should be considered as helpful suggestions, but not absolute truths. Always exercise critical thinking and cross-check information when making important decisions. Deeper learning activities. Network vulnerabilities. Describe what is meant by the term network vulnerability. Pass. The term network vulnerability refers to a weakness or flaw in a computer network security infrastructure that can be exploited by unauthorized individuals or malicious entities to gain unauthorized access, disrupt normal network operations, steal sensitive information, or cause other harm to the network and its connected systems. Network vulnerabilities can arise from various sources, such as software bugs, misconfigurations, outdated or unpatched software, weak authentication mechanisms, and inadequate security protocols. These weaknesses create opportunities for attackers to bypass security measures and gain entry into the network, where they can launch attacks or compromise the network's integrity, confidentiality, and availability. It is essential for organizations and individuals to identify and address network vulnerabilities proactively through regular security assessments, vulnerability scans, and patch management. By doing so, they can minimize the risk of cyber attacks and protect their network and sensitive data from potential threats. Explain the different network vulnerabilities merit and discuss why these vulnerabilities are specific to computer networks. Distinction. Network vulnerabilities are weaknesses or flaws in computer networks that can be exploited by malicious actors to gain unauthorized access, disrupt services, steal sensitive information, or compromise the overall network security. The Merit framework is commonly used to categorize different types of network vulnerabilities. Let's explore the various network vulnerabilities and understand why they are specific to computer networks. Misconfiguration vulnerabilities. Misconfiguration vulnerabilities occur when network devices, services, or applications are not properly set up or configured. This can lead to unintended access permissions, expose sensitive data, or the use of default credentials, making it easier for attackers to exploit the network. Specificity to computer networks. Misconfiguration vulnerabilities are specific to computer networks because networks consist of numerous interconnected devices and services. A single misconfiguration in any network component can potentially open up security loopholes throughout the entire network, amplifying the impact of such vulnerabilities. Exposure vulnerabilities. Exposure vulnerabilities involve open and accessible services or ports on network devices that can be exploited by attackers. When unnecessary ports or services are left open, they can become potential entry points for unauthorized users. Organizational vulnerabilities. Organizational vulnerability refers to the weaknesses and susceptibilities present within an organization that make it more susceptible to potential risks, threats, and negative outcomes. These vulnerabilities can stem from various aspects of an organization's structure, processes, or culture, and they can significantly impact its ability to achieve its objectives and withstand external or internal pressures. Understanding and addressing organizational vulnerabilities are crucial for maintaining resilience and ensuring the long-term success of the organization. Key elements contributing to organizational vulnerability may include security vulnerabilities. These pertain to weaknesses in organization security measures, such as inadequate cybersecurity protocols, physical security flaws, or insufficient risk management practices. Security vulnerabilities can expose the organization to data breaches, theft, or other security incidents. Operational vulnerabilities. These involve weaknesses in an organization's day-to-day operations, such as inefficient processes, lack of contingency plans, or over-reliance on a single supplier. Operational vulnerabilities can lead to disruptions, increased costs, or reduced efficiency. Financial vulnerabilities. These refer to weaknesses in organizations' financial management, such as high debt levels, cash flow problems, or poor financial planning. Financial vulnerabilities can make an organization susceptible to economic downturns or other financial crises. Explain the different vulnerabilities merit and discuss why these vulnerabilities are specific to organizations. Distinction. In the context of organizational security, vulnerabilities refer to weaknesses or flaws in an organization's systems, processes, or practices that could be exploited by malicious actors to gain unauthorized access, disrupt operations, steal sensitive data, or cause other harm. These vulnerabilities are often unique to organizations due to their specific structure, technology usage, and operational characteristics. The Merit model is a framework that classifies vulnerabilities into four main categories, each having distinct attributes and reasons for being organization-specific. Management vulnerabilities. Description. These vulnerabilities stem from inadequacies or deficiencies in an organization's management practices and decision-making processes. Organizational specifics. The way an organization is managed, its hierarchical structure, communication protocols, and leadership style can influence the presence and impact of management vulnerabilities. Example: poorly defined roles and responsibilities, lack of accountability, or ineffective oversight mechanisms are management vulnerabilities that could lead to security incidents. Employee vulnerabilities. Description. These vulnerabilities arise from the actions or inactions of an organization's employees, either intentionally or unintentionally. Organizational specifics. The size of the workforce, the level of security awareness training provided, and the organization's culture significantly influence employee vulnerabilities. Example: employees falling victim to phishing emails, sharing sensitive information unintentionally, or deliberately leaking data due to internal conflicts are employee vulnerabilities that may vary based on an organization's specific environment. Resource vulnerabilities. Description. Resource vulnerabilities relate to weaknesses in organizations' physical and technological assets, organizational specifics, the types of technology used, the level of maintenance and security updates applied to systems, and the physical security measures implemented can determine resource vulnerabilities. Example: using outdated software, insufficient firewall protection, or inadequate physical security for data centers or resource vulnerabilities that can vary between organizations. Information vulnerabilities. Description. These vulnerabilities are related to the confidentiality, integrity, and availability of an organization's information assets. Organizational specifics. The nature of the data an organization handles, the data storage and access policies, and the level of encryption used can impact information vulnerabilities. Example: storing sensitive data without proper encryption, granting excessive user privileges, or lacking secure data. Backup strategies are information vulnerabilities that may be specific to an organization. Why these vulnerabilities are specific to organizations? Organizations have unique characteristics, which means their vulnerabilities are not one-size-fits-all. The following factors contribute to the specificity of vulnerabilities to organizations. Diverse infrastructures. Organizations use various hardware, software, and network infrastructures based on their needs and budgets. This diversity creates a wide range of potential vulnerabilities. Varied data handling. Different organizations handle diverse types of data, such as customer information, financial data, intellectual property, or sensitive research. The protection requirements for each data type differ, leading to specific vulnerabilities. Customized policies and practices. Organizations adopt their security policies, procedures, and best practices. Weaknesses or deviations in these custom approaches can lead to vulnerabilities that are specific to the organization. Employee culture, the organization's work culture, and the level of security awareness among employees can impact how well they adhere to security protocols, affecting vulnerabilities. Budget and resource allocation. The amount of resources allocated to cybersecurity initiatives can significantly influence the number and severity of vulnerabilities an organization faces. Adoption of emerging technologies. Organizations might adopt new technologies at different paces, potentially exposing them to specific vulnerabilities associated with these technologies. Overall, understanding and addressing organization-specific vulnerabilities are crucial to enhancing an organization's security posture and protecting against potential threats and attacks. It requires a tailored approach to identify, prioritize, and mitigate the vulnerabilities unique to each organization. Software vulnerabilities. Describe what is meant by the term software vulnerability. PAS. A software vulnerability refers to a flaw or weakness in a computer program or software system that can be exploited by attackers to compromise the security of the system, gain unauthorized access, or cause it to behave in unintended ways. These vulnerabilities are unintentional errors or oversights in the software's design, coding, or implementation that leave it susceptible to exploitation. Software vulnerabilities can take various forms, including but not limited to buffer overflows. These occur when a program writes more data to a buffer temporary storage than it can hold, causing the access data to overwrite adjacent memory space, potentially leading to crashes or unauthorized code execution. Injection attacks, such as SQL injection, where malicious code is inserted into a system through input fields, exploiting inadequate validation and leading to unauthorized access or data manipulation. Privilege escalation. This vulnerability allows an attacker to gain higher levels of access to a system or application than they should have, enabling them to perform actions reserved for administrators. Cross-site scripting XSS. Attackers inject malicious scripts into web applications viewed by other users, compromising their sessions or stealing sensitive data. Explain the different vulnerabilities merit and discuss why these vulnerabilities are specific to software. Distinction. In the context of software, the Merit framework outlines for major categories of vulnerabilities: memory, environment, resource, and input/output vulnerabilities. These vulnerabilities are specific to software because they result from the complexities and intricacies of designing, developing, and executing software applications. Let's delve into each vulnerability category and discuss why they are unique to software. Memory vulnerabilities. Memory vulnerabilities are flaws related to how a software program manages and manipulates memory. Common examples include buffer overflow. This occurs when a program writes more data into a buffer temporary storage than it can hold, leading to the overwriting of adjacent memory locations, potentially causing program crashes or unauthorized access to sensitive data. Use after free. When a program continues to use a pointer to memory after the memory has been deallocated, it can lead to unpredictable behavior and security issues. Null pointer dereference. A null pointer points to no memory location. Dereferencing a null pointer can lead to crashes or exploitable vulnerabilities. These memory vulnerabilities are specific to software because they are inherent to how programs handle memory allocation, deallocation, and data manipulation, which are core aspects of software development. Operating system vulnerabilities. Describe what is meant by the term operating system vulnerability. PAS. Operating system vulnerability refers to a weakness or flaw in an operating system's design, implementation, or configuration that can be exploited by malicious actors to compromise the security, stability, or functionality of the system. These vulnerabilities can provide an entry point for attackers to gain unauthorized access, execute arbitrary code, escalate privileges, steal sensitive information, disrupt services, or perform other harmful actions on the affected system. Common causes of operating system vulnerabilities include coding errors, inadequate security measures, improper handling of user inputs, lack of timely updates, and misconfigurations. Hackers and cybercriminals actively search for and exploit these vulnerabilities to carry out various types of cyber attacks, such as malware injection, denial of service DOS attacks, privilege escalation attacks, and data breaches. Software developers and operating system vendors regularly release updates, known as patches, to address these vulnerabilities and improve the overall security of the system. Users and organizations are encouraged to keep their operating systems up to date to protect against known vulnerabilities and reduce the risk of successful attacks. Additionally, implementing proper security practices such as using firewalls, encryption, and access controls can help mitigate the impact of potential operating system vulnerabilities. Explain the different vulnerabilities merit and discuss why these vulnerabilities are specific to operating systems. Distinction. In the context of operating systems, the term merit stands for the four main categories of vulnerabilities that can affect them. These vulnerabilities are specific to operating systems due to their complex nature and the various components they consist of. Let's dive into each of these vulnerabilities and discuss why they are specific to operating systems. Memory vulnerabilities. Memory vulnerabilities are a class of security flaws that involve improper handling of memory by a program or the operating system itself. Some common memory vulnerabilities include buffer overflows, format string vulnerabilities, and use after free errors. These vulnerabilities occur when an application or the operating system accesses, reads, or writes to memory in an unintended way, leading to potential crashes or unauthorized access to sensitive data. Memory vulnerabilities are specific to operating systems because they are closely tied to the management and protection of system memory. Operating systems are responsible for memory allocation, process isolation, and enforcing memory protection mechanisms such as address space layout randomization ASLR and data execution prevention DEP if these memory management components are flawed or not implemented correctly. Memory vulnerabilities can be exploited by attackers to compromise the system. Execution vulnerabilities. Execution vulnerabilities refer to weaknesses in the way programs or the operating system execute instructions or handle system calls. Common examples of execution vulnerabilities include code injection, attacks like SQL injection and command injection, These vulnerabilities arise when an application or operating system fails to properly validate and sanitize input, allowing malicious code to be executed. Mobile device vulnerabilities. Describe what is meant by the term mobile device vulnerability. Pass. Mobile device vulnerability refers to a weakness or flaw in the security defenses of a mobile device, such as smartphones, tablets, or wearable gadgets. This vulnerability could be in the device's hardware, operating system, or applications, making it susceptible to exploitation by malicious actors or cyber attacks. There are several types of mobile device vulnerabilities. Operating system vulnerabilities. These are weaknesses in the mobile device's operating system, e.g., Android, iOS, that could be exploited by attackers to gain unauthorized access, steal sensitive data, or compromise the device's functionality. Application vulnerabilities. Mobile apps installed on devices may contain security flaws that attackers can exploit. Common vulnerabilities include insecure data storage, improper authentication mechanisms, and lack of input validation, among others. Network vulnerabilities. Mobile devices are often connected to various networks, cellular, Wi-Fi, Bluetooth, which can expose them to different network-based attacks. Unsecured networks may allow eavesdropping or man-in-the-middle attacks. Explain the different vulnerabilities merit and discuss why these vulnerabilities are specific to mobile devices. Distinction. In the context of mobile devices, the Merit framework outlines for major categories of vulnerabilities: malware, exploits, risky apps, and information leakage. These vulnerabilities are specific to mobile devices due to their unique characteristics and usage patterns. Let's delve into each of these vulnerabilities and explore why they are more prevalent on mobile devices. Malware. Malware refers to malicious software designed to compromise the security and privacy of a device. Mobile devices are highly susceptible to malware for several reasons. App ecosystem. Mobile app ecosystems, such as Google Play Store and Apple App Store, host millions of apps, some of which may contain malware. These app marketplaces lack comprehensive security checks, making it easier for malicious apps to slip through. Sideloading. Users can install apps from third-party sources outside official app stores, which exposes them to higher risks of malware. Limited resources. Mobile devices often have limited processing power and memory, making them more susceptible to resource-intensive malware that can slow down or crash the device. User behavior. Mobile users tend to be more trusting and less cautious while installing apps or clicking on links, increasing the chances of inadvertently downloading malicious software. Physical device vulnerabilities. Describe what is meant by the term physical device vulnerability. Pass. The term physical device vulnerability refers to a security weakness or flaw in a hardware device that makes it susceptible to unauthorized access, manipulation, or exploitation. These vulnerabilities can be inherent in the design, manufacturing, or deployment of the device, and they pose a risk to the confidentiality, integrity, and availability of the information or services that the device handles. Physical device vulnerabilities can manifest in various ways. 1. Design flaws. Inadequate security measures during the design phase can create vulnerabilities. For example, weak encryption protocols, improper authentication mechanisms, or backdoors left by the manufacturer for debugging purposes. Manufacturing defects. Errors introduced during the manufacturing process may lead to vulnerabilities, for instance, compromised components, unintentional inclusion of malicious code, or incorrect hardware configurations. Physical access. Devices can be vulnerable to attacks. When they are physically accessible, an attacker with physical access might tamper with the device, extract sensitive information, or install malicious hardware or software. Environmental hazards. Some devices are sensitive to environmental factors, such as extreme temperatures, humidity, or electromagnetic interference, which could compromise their functionality and security. Explain the different vulnerabilities Merit, and discuss why these vulnerabilities are specific to physical devices. Distinction. In the context of physical devices, the Merit framework represents for different types of vulnerabilities. Mechanical vulnerabilities. Mechanical vulnerabilities are associated with the physical components of a device. These vulnerabilities arise from weaknesses in the design, construction, or materials used in the device's physical structure. For instance, a weak casing or poorly secured connectors could lead to physical tampering, unauthorized access, or damage to the device. Electrical vulnerabilities. Electrical vulnerabilities pertain to weaknesses in the electrical systems of a device. These vulnerabilities can be exploited by attackers who manipulate the device's electrical inputs, power supply, or electrical signals to compromise its normal operation. Common examples include power surges, voltage spikes, or electrical shorts. Radiation vulnerabilities. Radiation vulnerabilities refer to issues related to electromagnetic radiation emitted or received by a device. This includes both intentional and unintentional radiation. Attackers can use electromagnetic interference to disrupt the proper functioning of the device or even extract sensitive information through unintended electromagnetic emissions, i.e., electromagnetic eavesdropping. Information vulnerabilities. Information vulnerabilities center around the data and information processed or stored by the physical device. Weak encryption. Inadequate access controls or insufficient data protection measures can lead to data breaches or unauthorized access to sensitive information. Describe what is meant by the term cloud computing vulnerability. Pass. Cloud computing vulnerability refers to a weakness or flaw in the infrastructure, applications, or services of a cloud computing environment that could be exploited by malicious individuals or entities to compromise the security, integrity, or availability of data and resources. Cloud computing vulnerabilities can arise from various factors, including misconfigurations, software bugs, inadequate security measures, and human errors. Common cloud computing vulnerabilities include 1. Insecure authentication and authorization. Weak or poorly implemented authentication mechanisms can lead to unauthorized access, while improper authorization settings may allow users to access data or resources they should not have permission for. Data breaches. Cloud providers stored vast amounts of data from multiple customers. A vulnerability in the system could expose sensitive information to unauthorized users. Insecure APIs, application programming interfaces (APIs), are essential for communication between different cloud services. If an API is poorly designed or lacks proper security measures, it could be exploited by attackers to gain unauthorized access to the cloud resources. Data loss, insufficient data backup and recovery mechanisms, or hardware failures could result in data loss, impacting businesses and customers. Denial of service DOS attacks. Attackers may try to overwhelm cloud services or applications with excessive traffic, causing disruptions and denying legitimate users access to resources. Explain the different vulnerabilities Merit, and discuss why these vulnerabilities are specific to cloud computing. Distinction. In the context of cloud computing, the Merit framework is used to categorize different types of vulnerabilities that can arise. Merit stands for misconfiguration, elevation of privilege, data breach, insecure APIs, and token vulnerability. These vulnerabilities are specific to cloud computing environments due to the unique architecture and shared nature of cloud services. Let's delve into each vulnerability and understand why they are particularly relevant in the cloud. Misconfiguration. Misconfiguration refers to the improper setup or settings of cloud services and resources, which can lead to security weaknesses. Cloud environments are complex and dynamic, involving multiple services and configurations. If cloud providers or users misconfigure settings, it may leave sensitive data exposed, grant unauthorized access, or create avenues for attacks. Cloud-specific challenges. Cloud environments often offer a vast array of configuration options, making it challenging for users to understand and apply secure settings. Rapid scaling and frequent changes in cloud infrastructure can increase the likelihood of misconfigurations going unnoticed. Elevation of privilege. Elevation of privilege involves unauthorized users gaining higher levels of access and control over cloud resources than they should have. This can result from exploiting vulnerabilities or weak access controls. Attack vector. Describe what is meant by the term attack vector. Pass. The term attack vector refers to the specific method or path that a malicious actor or attacker uses to gain unauthorized access to a system, network, or application with the intent of compromising its security or causing harm. Attack vectors represent the various avenues or vulnerabilities through which an attacker can exploit weaknesses in a target system's defenses. Attack vectors can take many forms, including 1. Social engineering, manipulating individuals through psychological means to disclose sensitive information or perform certain actions, such as clicking on malicious links or sharing confidential data. Phishing, sending deceptive emails or messages that appear legitimate to trick recipients into revealing personal information, or downloading malicious attachments. Malware, distributing malicious software malware through infected files, email attachments, or compromised websites, which, when executed, can grant unauthorized access or control to the attacker. Brute force, attempting to gain access to a system by repeatedly trying all possible combinations of usernames and passwords until a valid one is found. Denial of service DOS and distributed denial of service DDoS, overwhelming a target system or network with excessive traffic to make it unavailable to legitimate users. Explain the different attack vectors' merit and discuss methods that can be used to reduce their risks. Distinction. Sure. Let's explore different attack vectors and methods to reduce their risks. 1. Malware. Malware includes various types like viruses, worms, trojans, ransomware, and spyware. It can infect systems and cause damage or provide unauthorized access to attackers. Risk reduction methods. Keep software and operating systems up to date with the latest security patches. Use reputable antivirus and anti-malware software to detect and remove malicious programs. Educate users about the dangers of downloading files from untrusted sources or clicking on suspicious links. Implement application whitelisting to only allow authorized software to run. Phishing. Phishing involves sending deceptive emails or messages to trick users into revealing sensitive information, such as login credentials or financial data. Risk reduction methods. Educate users about phishing techniques and how to identify suspicious emails. Implement email authentication techniques like SPF, DKIM, and DMARC to prevent email spoofing. Use security awareness training to teach employees how to recognize and report phishing attempts. Deploy anti-phishing tools that can analyze and block suspicious emails. Research different sources that you can use to keep up to date on specific known hardware and software vulnerabilities. Pass. Keeping up to date on specific hardware and software vulnerabilities is crucial for maintaining the security of your systems. Here are some reliable sources you can use to stay informed about the latest vulnerabilities. National Vulnerability Database (NVD). The NVD is a U.S. government repository that provides information on security vulnerabilities, including their severity, impact, and solutions. It's an authoritative source for vulnerability information. Common Vulnerabilities and Exposures (CV). CV is a list of publicly disclosed cybersecurity vulnerabilities. It provides unique identifiers for vulnerabilities and links to related advisories and patches. Security mailing lists. Subscribe to security-focused mailing lists like BugTrack, Full Disclosure, and Daily Dave to receive timely updates on newly discovered vulnerabilities. Security blogs and websites. Follow security blogs and websites that regularly publish vulnerability reports and security news. Examples include Krebsen Security, The Hacker News, and ThreatPost. Vendor security advisories. Keep an eye on security advisories published by hardware and software vendors like Microsoft, Apple, Google, Cisco, etc. They often release patches and updates to fix vulnerabilities.
Thanks for watching. For more information, like, comment, and subscribe our channel.